Alright, let's take a look at recognizing average rate of change in these graphs. Okay, so the following graph shows the amount of paint needed to paint the door of a house. The doors of a house. Use the graph to answer question 1 and 2. So remember, when we're dealing with a linear function, the average rate of change okay, is the same no matter which points we pick. So it's basically the slope. Now, when we look at these questions, it says what is the approximate rate of change for the interval 2, 7 or interval 12, 19. So these intervals are just giving us the x values of the points that we're dealing with. So x value of 2, my point would be right here. X value of 7, my point is right here. And yes, those are slightly off, because it's hard to get them just right sometimes. So if I look at this, okay, so I've got, so with slope or rate of change, it's the change in the y value over the change in the x. So the vertical change over the horizontal change. So from 2 to 7, that horizontal change is going to be 5. Okay, so that goes on the bottom of my fraction. Now the vertical change, this is probably at about 0.1, and this is 0.4. So 0.4 minus 0.1 is 0.3. So we have 0.3 over 5, okay, which we can reduce or divide, and we get 0.06. And what that means is for every door, we use 0.06 gallons of paint. Okay? So gallons of paint per door. Alright. So then 12 to 19, same idea. 12 would be this point right here. We'll call that 0.7 to make it easier. Okay. And 19 right here. We'll call that 1.1. Okay. So difference of 19 to 12 would be 7. So that's what goes on the bottom. Difference of 0.7 to 1.1. So 1.1 minus 0.7 would be what? 0.4. So 0.4 over 7. So 0.4 gallons per 7 doors. Which, if we simplify that, we should get the same thing, right? 0.4 divided by 7. Roughly 0.057, which because we were just, estimating on some of these, basically the same thing. Because it's linear. Alright? Okay, let's take a look at the next one. So now, the value of the US dollar compared to the value of the Australian dollar on a specific date. Okay? So, looking at this, what is the approximate rate of change for the interval 10 to 25? Okay, so 10 to 25 is right there. So about 10 to about, let's see, those are by 5, so that's probably 24, which means this is probably 9. So the change in y is 24 minus 9 over the change in x, 25 minus 10, right? So 24 minus 9 would give us what, 13? Or 15, there we go, 15. Over 25 minus 10 would be 15. So it's roughly 1. Okay, so the rate of change would be basically the same, right? 1 US dollar would be worth 1 Australian dollar. Now, if we go to 30 to 65, because it's linear, so it should still be the same, right? Okay. Right about there. And 30's right there. 30's probably like 29. And up here would look like 62. So 62 minus 29, which would be 33, and 65 over 30, right, or 65 minus 30, which would be 35. So it's slightly off, but again, it's because we're kind of, that could easily be 33 and 28, which is probably closer to what it would have been. Being that it's linear, we should have the same thing. So 35 over 35, again, gives us 1. So could we predict the rate of change for a third interval? Yeah, it would be the same thing. It would be 1, okay, because it's linear. All right, now if we're looking at one that's not linear, okay, that's where it's going to be different. So each year, volunteers at a 3-day music festival record the number of people who camp on the festival grounds. The following graph shows the number of campers for each of the last 20 years. Use the graph to answer questions 6 and 7. So 3 to 9 for rate of change. 3 is right here. Okay, we'll estimate that to be, let's see, 1,000 to 1,500. Maybe we'll call that 1,450 for the y value. And then we're going to 9, so 9 is right above 2,000, so we'll go 2,050. So again, I take the y values and subtract them, right, on the top of the x values subtracted. So we get 6 on the bottom, and then what is it, 600 on the top, which 600 divided by 6 would be 100. So basically every year we have 100 more campers. Grows by 100 per year. Okay, now we want to go from 9 to 16. So we've already got 9. So now 16, we'd maybe say was 3050. Okay, so we'd go 3050 minus 2050 over 16 minus 9. Okay, that would be 1,000. 16 minus 9 give us what, 8, 7. Okay, 1,000 divided by 7 would give us about 142.85, so 142. So more in that. Those other years we had more, didn't we? 142 per year. More campers per year, as opposed to 100. Because it's that curve, so it's not constant like the linear was. Alright, the last one. So yearly population of a small town, looks like it's decreasing. So interval from 1 to 6, one we put right up there, we'll call that one 5,400. No, let's do 5,450. I think that's a little closer. And then up to 6 we'll call 4,550. So I'd go 4,550 minus 5,450 over 6 minus 1. So the bottom would be 5. The top, 4,550 minus 5,450. Because it's going down, negative 900 divided by 5 will give us negative 180. So basically every year we lose 180 people in the population. Okay. Now what about year 10 to year 20? It's pretty easy about the years, right? 20 minus 10 would give us 10. But what about, let's estimate the y's. So this one's probably 3950 for the 10. And then that one looks right smack dab in the middle, so it'd be 2750. So again, 2750 minus 3950. That gives me negative 1200 divided by 10 would be negative 120. So now from years 10 to 20, we're losing 120 people per year. Okay, so how does the rate of change differ for each interval? Well, as we can see, it's different, right? Based on which interval we're doing, because it's that curve. that as it evens out, it has a lower rate of change. Okay? All right, there we go.